My name is Pranoti and I am the student of Sardar Patel Institute of Technology. Today my team and I will be presenting on a topic types of filter in electronics and telecommunication branch guided by Professor Najib Ghatte. Our team members each have a specific role for this presentation. Akib will handling the MATLAB simulation to demonstrate the filter behaviors. Adnan will work on a multisim simulation to showcase the practical circuit implementation. Together we aim to give comprehensive overview of the different types of filters and their applications. Now welcome to our presentation. What are the filters? In a signal processing, a filter is a device or a process designed to remove certain unwanted components from a signal. Essentially, filters are used to either suppress or allow specific accepts of a signal, often by frequency ranges. Filters play a key role in a refining signal for different applications such as improving audio quality, enhancing radio signals and processing data for electronics. Let's now explore the main types of filters. So basically there are three types of filter. First is low pass filter. Low pass filter often abbreviated at LPF is designing to pass signals which frequencies lower than a specific cutoff frequencies and to attenuate frequency higher than the cutoff. These types of filter is widely used in audio application where only low frequencies like bass sound need to be transmitted. The cutoff frequency formula for a simple low pass RC filter is represented as Fc is equal to 1 upon 2 pi RC, where the R is the resistance and C is the capacitance. Now next is a high pass filter. A high pass filter allows frequency higher than the cutoff frequency to pass while attenuating the frequencies below that point. This is useful in applications where only high frequency signal need to be proceed, such as a creatable sound in an audio system. High pass filter can also be beneficial in a removing unwanted low frequency noise from a signal. Now next is a band pass filter. A band pass filter allows a specific ranges of frequencies to pass through while blocking frequencies outside this range. This is useful in applications like radio communication where the only particular frequency ranges is needed, or in a musical instruments where specific frequencies need to be isolated. Band pass filters are the often used in a wireless communication system to transmit only the set band of frequencies. Now cutoff frequency. Here we see the general formula for determining the cutoff frequency, which is essential to filter design. In the case of RC circuit, the cutoff frequency can be calculated as Fc is equal to 1 upon 2 pi RC. This is the formula given the point where the output power of the filter drops to half of the passband power level, effectively defining the boundary level between the passband and the stop band frequencies. Now the applications of a filters. Filter have a numerous applications across the filter industries. First is a radio communication. Filter allows these radios to isolate the desired frequencies while rejecting others, improving signal clarity. Next is a power supply. Filter in a power supplies reduce noise and ensure clean, steady out voltage. Next is a audio electronics. Crossover network in an audio system use filter to send low frequencies to woofer, mid frequencies to mid-range speaker and high frequencies to tweeters. Now next is an analog to digital conversion. Filters help prevent aliasing by cleaning up signals before they are slamped, ensuring accurate digital representation.
So as we have seen the theoretical background of passive filter, now let's see how we can design a low pass, high pass and band pass filter using a MATLAB. So first of all, we have written a clear and CLC command to clear the workspace and the command window. Now let's set the parameters for each filters. First of all, we have set the resistor and capacitor value as 3.9 kilo ohm and 2 nanofarad, and we have taken a cutoff frequency for low pass filter which is 2 kilohertz. Same values we have taken for high pass filters, and its cutoff frequency is also 2 kilohertz. Afterward, we have taken a band pass filter. For band pass filter, we have made a two section. First is a low pass section and second is a high pass section. For low pass section, we have taken same values of resistor and capacitor and same as for high pass. Now let's define the frequency range for plotting. We have taken a frequency range from 1 Hz to 100 GHz to see our frequency response of these above filters. After that, we have taken the transfer function of a low pass filter. This is the formula of this is the formula of our low pass filters transfer function. Afterward, we have taken the transfer function of a high pass filter, and this is the formula for that high pass. After low pass and high pass, we have taken a band pass transfer function. For that, first of all, we have taken a transfer function of low pass, and then we have taken a transfer function of high pass section of band pass, and then we have combined both low pass and high pass to get a band pass transfer function. After this, we have plot a frequency response. For visualizing the response of low pass, high pass, and band pass, we will require three figures to visualize these filters. So we have taken a subplot 3, 1, 1, in which we will use a semi-log graph on which we will see the frequency response of low pass. Here I have given a title low pass filter frequency response. On my x-axis there will be a frequency in hertz, and on y-axis I am putting a magnitude in decibel. Same I have given for high pass. Here I have given a subplot 3, 1, 2. So this will be my second figure, and I have given title X label, Y label same as a low pass. Afterward, I have taken a subplot 3, 1, 3. This will be my third figure, which is of band pass filter. And here I have given a title of band pass filter frequency response. And my X label was frequency in hertz and Y label was magnitude in decibel. So now, after running this code, I have of this. Here we can see I've got a three figures. First is the low pass frequency, second is a high pass filter frequency, and third is a band pass filter frequency. Here in first figure we can see as we have given a cutoff frequency of 2 kHz. So here we can see that after a 2 kHz the signal is get attenuated. Same in high pass high pass filter uh, after 2 kHz, the signal is not attenuated, but before 2 kHz, the signal is get attenuated. And in band pass, we have taken a same frequency range of 2 kHz. So after and before the 2 kHz, we can see the attenuation in signal.
Hello everyone, my teammates have just explained the theory behind filters and demonstrated the MATLAB code. Now I will take you through the practical implementation of filters using Multisim. Here I made the low pass filter with the cutoff frequency 20 kHz. Let's run interactive simulation first. Here we can see the output on oscilloscope. Let's increase the frequency to see how the filters react. We can see that after cutoff frequency, the amplitude start decreasing. This filter only pass low frequency and block high frequency. For a better understanding, let's run AC swap simulation. You can see that frequency response of low pass filter after 20 kilohertz, the magnitude start decreasing. Let's move on high pass filter. Here I made high pass filter with the same cutoff frequency 20 kilohertz. Let's run interactive simulation first. Let's start increasing frequency. You can see that after cutoff frequency, the amplitude start increasing. This filter only pass high frequency and block low frequency. For better understanding, let's run interact AC swap simulation. So this is the frequency response of high pass filter. After 20 kilowatts, we get the peak voltage. Let's move on band pass filter. So here I made the band pass filter with 20 kilowatts frequency. Let's run interactive simulation first. Let's start increasing frequency. We can see that this filter block low frequency and also block high frequency. We get the cutoff frequency at the output. For better understanding, let's run AC swap simulation. We can see that at 20 kilohertz, we get the peak output, peak voltage. Of before 20 kilowatts, the magnitude decrease, and after 20 kilowatts, the magnitude also decrease.
So, at last, by concluding this practical, we have designed a different type of passive filter using MATLAB code and a multisim. Thank you. If you love this video, please like and subscribe the channel.